So this is my servo engraver. It has two 18-inch axes on it. Originally it came from an XYZ Cartesian robot. Has really good linear bearings and little lead screws. The Z is actually fairly strong too. Right at the moment I have a 1 horsepower Colt router on it. I can actually put that head unit that's off of my little milling CNC. That little head unit's pretty neat. It's got different speeds, variable speed on it also. With the controls here, I'm using this Ethernet smooth stepper. I actually take this back and forth between the two machines. That control box there. So this is what I'm replacing. I had an X drive, a little Geco drive. This is an X drive I had mounted in there and wired up. I temporarily just have wire nuts on as I tie it into my amp connector. It used to be my encoder feedback. It was the power to the motor on the brushes on the motor, and then there was encoder feedback, and I changed it, tied them in to the circular amp connector, and was able to tie them in coming straight off the actual motion control board for step and direction use. I still have my Y and my Z wired up the same way as it was. The reset is for the Geco servos in event of a fault. Just my 5-volt enable supply with a DC to DC converter there. So this is my servo engraver that I'm putting this Teknic stepper killer on, the all-in-one servo. I'm going to include some footage now of this same machine when I first got it up and running. And you'll see that it's got the pittman servo for the X on the video when I was engraving some house signs at a previous residence I had. I was engraving some house signs for the neighborhood, and I did take a quick video of it. So I'll insert it now just so you can see how it done with the original servo on it. So today I just thought we would look at the software. Version 1.2 is what I got. I've had the software for a couple years. But this is the motor that I'm wanting to replace for my X-axis. Probably going to take that coupling element off so it won't sling it. But I have the actual step and direction and the enable plug loose. I just have the power plug going to it. If I cut on my emergency stop, will actually give me, it enable and actually give me my 48 volts output. I just have a USB cable hooked up. put them to the drive motor combo. It does show here clear path motor found, testing communications. Okay, verify tuning. So at this point, I have 12,800 set up for our input resolution on the pulses per revolution. If we click override inputs, I can actually enable. Right now it's not enabled. As I turn the shaft, we can see the counts, velocity. Bring this a little bit closer. Make sure we can see the screen okay. So I've enabled my inputs. Now I can enable the drive. It tells me my servo on output, servo on. It is a step and direction input servo. So I can actually change the direction here, jog counterclockwise, or I can jog clockwise, depending on the direction enable that I do. So velocity 40 RPM. If I hit jog, it jogs at 40 RPM. My position counts are going down. I can switch direction, jog, and I go back down close to 0, or up towards 0, go more positive. I can change my velocity all the way to 4,000, and my acceleration RPMs per second is 2,000. It is really smooth. I can do 100 RPMs per second. And even though I got it set for 4,000, I got to hold it down for a while. We can actually see the RPM increase slowly on a velocity readout. If you release it, it's going with the same decel rate when you release it. There's a couple other things we can do on this screen. We had a 100% torque. So we take this motor, it's wanting to fight pretty hard. I can't turn the shaft. If I reduce this to say 5%, just 5% torque, so I can move the shaft and it'll show you that the torque is saturated. We can also expand this screen, and we can have a little scope down here. Right now the scope variable is set for phase, max phase voltage. I'm going to put the acceleration back on 2,000 RPMs per second. And we see the voltage rise up and stay, release, drops pretty quick. So this gives us some more troubleshooting tools on running the motor. Under setup, we have a auto tune. We have to disable it. Warning, yes. We'll leave the torque limit at 100. It's making sure we want to leave the torque limit at 100%. It knows that this motor I have is a 284 ounce inches or 2.01 Newton meters. So I can select. That's pretty neat. If it's on a machine and you're scared you'll crash it, then you can actually limit that torque. You can limit the rotation. In my case, I can do unlimited. It's just on the table. Shaft rotates freely in both directions. Yes. There's no direction limitations on mine. Is all these settings correct? Yes. Next. It's telling you what's going to happen. Buzzing, fast, abrupt moving. We'll watch the shaft and see what it does. I do have to hit run. Okay. I have to hit run auto tune. Now we are auto tune in progress. Since we're only at 3%, I will fast forward the video through the parts that this seems to be the same until it hits a spot where maybe starting to spin up, spin down, maybe doing a little bit different. We actually get the option to be able to move it. We can move it plus or minus. We can change the speed here. Alright, so we must disable it. So you need to move it to a location that lets you have the ability to do that before you disable it. That's neat. Step and direction mode. There we go. So there we go. We can enable it again. We should be able to run it. So we have our resolution set at 12,800 pulses per revolution. I got that wrote down so I can set my software up on my CNC machine in Mach 3. My ball screw is 10 turns per inch, so I should be able to put that number in directly and see how close it is in the move. I'm going to close this software now. Put the plug back over the communication port. I now have my communication cable hooked to my CNC. I'm going to launch my servo engraver is what I call it. So now I'm going to actually hook up my step and direction enable. I now have my enable. I'm blinking green. It is definitely trying to hold position. It is jogging with my commands like it should. jogging at 100%. Let's go 10%. Man, it's smooth and quiet. So this is how I have it configured. Motor tuning on the X-axis. This is steps per unit. And that's the velocity that I'm using is 100. And actually I have acceleration at 50. The only reason I have it limited to 100 is because that's inches per minute. As my other servos are still limited to that, so I'm just trying to keep them the same until I can eventually at least get my Y retrofitted to have one of these also. I'm gonna put it on and we'll see how it does. We'll do a reset. Got my blinking green. Got my green blink. It's enabled and good. Software is up. Let's see if the X will move. There we go. Go to 1% jog. We go to 5% on the jog. Very smooth. Let's try 50%. Let's go to 25%. See if we can get that wider jog. Get to Z. All axes are working. That's at 50%. What I did is I regenerated the tool path. I re-zeroed all the axis to right here being 0. We'll see if it'll do a program. I don't have the spindle, the actual router hooked up right now. So I have my program loaded. I have a legend plate down here with a This is a diamond tip engraver. I just got it stuck in my router, but it's not going to rotate. It's going to stay stationary. Just got a plunge to help protect the diamond and just to keep a good tension on it. So I'm just going to bring over the remote I got hooked up. We'll go to origin point, which I got my 000 set. And we'll just do a cycle start. It took 13 seconds to do that program. I'm going to now load my next G code. We'll pick another program I created. I did have to change that program a little bit. It's going to be a little bit smaller, and I got the letters a little closer together. And I simply jogged it to make sure. You can see here I got my cursor. The actual purple cursor is on the right side of subscribe. So it's going to be there to there. So yeah, that should fit just fine. I'm going to go back to origin point. That's going to be my 000. Cycle start. That one took 37 seconds. The X motor replacement worked really well. I hope to get the actual Y servo changed out pretty soon. It's starting to give a little bit of trouble also from time to time. So I just thought I'd share that video today about swapping over an older brush DC motor with the newer all-in-one Teknic. They call it the stepper killer. So really easy to incorporate into a step and direction mode. They do make a lot of different modes, some by position, some that work on 0 to 10 volts. You can buy different configurations of these, so they are pretty neat little servo motors. It actually can save you a lot of room also. This cabinet that I built about 10 years ago, it wouldn't have to be near as big. If I actually would have incorporated these that come with the little plugs, I wouldn't actually necessarily had to have these amp circular connectors here. I just could have put cord grips in, and then also I wouldn't have had to have near the metal box here either. So I hope you enjoyed that video today and learned a little something about the newer style servo motor. If you like the video, please give it a thumbs up.